Okay, so this is a introduction into iGCSE physics with induction, section 6D. So voltage is induced in a conductor or coil when it moves through a magnetic field or when a magnetic field changes through it. So there we've got my magnet. I push it into the coil or loop of wire, and the galvanometer, which is like a sensitive ammeter, will show a potential difference or a current moving through the loop. Now, of course, if I pull the magnet the other way, it's going to reverse. Or if I push it in and then I move the south to the other side and pull the south out, then the needle reverses. So that is induction. Now, transformers is all about changing the size of an alternating voltage by having a number of turns on the input and output side. So here we've got a transformer core that looks a bit like a donut, and we've got a primary coil. So this is a coil of insulated wire, and across it, we have an alternating current and an alternating potential difference. So constantly, this is alternating just like the trace at the bottom here. Well, if that happens, what would I create? Well, I induce a magnetic flux that works around the transformer core one way and then back and one way and back. So they don't create power, but what it does is it passes through a current. So we have a current here and we have a magnetic field, and this induces or creates a alternating potential difference in a secondary core. Now the clever bit is we can change the number of turns, and due to the right hand grip rule, here we'd have lots of turns, here we have less turns, so I have a high potential difference, and this steps down the potential difference to a lower potential difference, but it increases the current because the power should equal the power that goes in. So power input should equal power output, which is one of our formulas. And you can see here the other key part of the maths is potential difference on the primary, potential difference on the secondary, and the number of turns on the primary and the number of turns on the secondary. So I find the ratio you can either do of primary to secondary with potential differences, or you can do primary on one side, secondary on the other, like this one is. So the voltage, potential difference on the primary divided by the number of turns will give you the voltage on the secondary divided by the number of turns on the secondary. So what happens is I can transform my energy, and by transforming it in something called the national grid. So there's a power station, we transform it, we step up the potential difference, then we step it down when it comes to our homes. By stepping it up, we find that we can reduce the power loss. Now, typically, if it was a perfect situation, input power equals output power, voltage on the primary times current on the primary equals voltage on the secondary times current on the secondary. But we often find that transformers are not 100% perfect, and you could work out, if you know the resistance and stuff in the wires, the power loss, which comes out at I squared R. So if I reduce the current quite a lot, I reduce the power loss, and this is why they step up the current to go down the transformer lines, and then they step it down again later. Transformers are made out of soft iron, a soft magnetic material, so it can easily magnetize and demagnetize. That helps keeps it cool and lowers wasted energy. We would never use steel because steel is hard to magnetize. So we don't want a permanent magnet, we want something that can be magnetized and demagnetized. Other part of this topic is generators. So the generation of electricity is by a rotation of a magnet within a coil of wire and of a coil of wire within a magnetic field. And we've got to describe the factors which affect the size of the induced voltage, and we've got to use Fleming's right-hand rule. So you can see we've moved to a different hand now, because what we're doing is we've got motion, we've got a field, and we're creating a current. You can see a typical setup here for a generator with slit rings connected, and effectively when the coil of wire is turned within the magnetic field, we're making a continuous contact between the slit rings, and we produce an AC, an alternating trace. And this is why we use transformers to adapt the current flow, because it's an AC trace. They've got to be an AC input for it to happen. It doesn't work with DC. And bearing in mind as well, one thing to mention is the frequency usually of mains is 50 hertz. Just a reminder, going back to year 9 content. So there you go. That's 6D induction.